Hello, yo, welcome back. All right, so here we're going to be looking at more question on matrix and determinant. Okay, now in this part of the video, we're going to be looking at a lot of question on matrix. Okay, um, the question that we actually treated previously are mainly the determinant of matrix. So we're going to look at more question on matrix. Okay, so I'm going to start with the very first question here. Right, so solution. Okay. Okay, so the question goes this way. So given that P is actually a matrix of 2 minus 3, 1, 1, okay? So we are to evaluate the inverse of P inverse. All right, P inverse, that's what we are looking for. All right, solution. Already I've written solution. Okay, so now the inverse of a matrix, please take note of this. The inverse of matrix is always given by the adjoint of that matrix. So the inverse of P is the adjoint of P. Then, of course, divided by the determinant of P. All right. So now the question is, how do we find the adjoint of P? Okay. The adjoint of P is simply the transpose of the cofactor. So what you're going to do, first of all, before I can get the adjoint of P, I have to find the cofactor of P. Cofactor. All right. So cofactor is simply the place value of the minor of that matrix. Of course, these words might be too big, and of course, it might be sounding so confusing. But I will simplify them as much as possible. All right. So now, the cofactor of P simply is going to be the minor. Now, each of the element of this matrix P is having a minor, all right? Of course, the minor of the element of each of this element is gonna be the element you get after you cross the row of that element and the column of that element, all right? For example, okay, the minor of 2, all right? The minor of 2 is gonna be the element I have if I cross the row of 2. If I cross the column of 2 and cross the row of 2, the element I have left becomes the minor. All right, so that is gonna be 1. Okay, so let me write that 1. Now later we'll talk about the place value. Okay, so let me write that 1. Then I now go to minus 3. The minor of minus 3, know exactly what it's gonna be. Okay, the minor of minus 3 is gonna be also 1. Okay, so coming to this place, the minor of 1 here is gonna be minus 3. Okay, so now there's one thing you should actually know. I'm not just going to be writing the minor, I also write the place value of the minor. If the minor is at an even position, I will give it positive value. If the minor, of course, if that element, please, not the minor, if the element is at even position, I will give it positive value, all right? If it is at odd position, I'll give it negative value, okay? Like at this point, the very first element is at the position of column 1, row 1. That is, the very first element is positive. The second is negative, all right? The third is positive, and the fourth is negative, all right? So this is positive. This one here is negative. Then here, this is going to be positive, okay? So positive of minus 3 will still give me minus 3. Now here is this going to be negative, all right? So the minor of course, this one right here is 2. Negative of minus 2 is going to be negative. All right? So that is the cofactor. That is how we evaluate cofactor. Please pardon me. That is how we evaluate cofactor. So now, having gotten the cofactor of that matrix, we can now find the adjoint. Adjoint is the transport of the cofactor. So the adjoint of P all right, is actually the cofactor, the transpose of the cofactor of P, then transposed. So how do we transpose a matrix? We transpose the matrix by changing the row to column. So the first row will become the first column. That's going to be 1 minus 1. Second row becomes the second column. Minus 3 minus 2. All right. So that is the adjoint. So now, having gotten the adjoint, now we can now find the inverse. All right. So to find the inverse, first of all, remember we need to divide the adjoint of P by the determinant. Of course, the determinant of the matrix. Let's do that. So the inverse of P now is going to be equal to the adjoint. All right, the adjoint, which of course is 1 minus 3 minus 1, then minus 2, then of course divided by the determinant. Of course, you know how we find the determinant of the matrix. The determinant of this matrix is simply going to be 1 times 2, then minus 1 times minus 3. Okay, so 1 times 2 is 2, minus into minus 3. Okay, so this is going to be 1 minus 3 minus 2, 1 minus 3 minus 1, then minus 2 divided by, of course, this is going to be 2 plus 3, which is 5. All right, so we can now write the final answer. Here we go. So the final answer now is going to be the inverse of P is going to be equal to 1 divided by 5. That's 1 all over 5. All right. Of course, minus 3 all over 5. I'm dividing everything by 5. Minus 1 all over 5. Then, of course, minus 2 all over 5. So that is the inverse of that matrix. So I hope that is well understood. All right, so here I have another question here. Okay, so this is, I have three matrices. Okay, so I'm being asked to find the value of x and y respectively. So I have the first matrix, this matrix plus this matrix gives me this. Okay, so what I'm going to do is I'm going to add the left hand side. You know how we add matrix? Simply we add the element in their various position. Okay, so we add the element in their various positions. So I'm going to have 1 plus x. Then, of course, 0 plus 1. Here I'm going to have minus 1, of course, plus minus 1. Okay? Minus 1 plus minus 1, which is still minus 1, right? Then for this, I'm going to have minus 1 plus 0. This, of course, I'm going to have 2 plus y. Okay? Then, of course, 2 plus minus 2, which, of course, is the same as 2 minus 2. All right, so it's equal to the matrix right here, minus 2, minus 2, minus 3, 1, minus 1, 0. Okay, so let's work on this. So it's just very easy. All right, it's very simple for me to be able to find x and y. So for me to find x and y, I have to equate. So I'm going to equate 1 plus x. Okay, of course it's equal to minus 2 because they are in the same position. All right, so with what I have now, I can now conclude that x is equal to minus 2, of course, minus 1, which is minus 3. For me to find y, I'm going to equate 2 plus y is equal to minus 3. Okay, so from what I have here, I can now have that y is equal to minus 3 minus 2, which of course is minus 5. As simple as that. Okay, so the same similar question, but this time around, this has to do with multiplication. So I'm not adding this time, I'm multiplying, all right? So multiplication of matrix is different from the addition. In addition, we add the element at the same position, okay, for the two matrices. But in matrix multiplication, we multiply the row against the column. So in matrix multiplication, look at what you're going to do. I'm going to use the first row, multiply the first column. All right. Use the same first row, multiply the second column. Then I'll go to the second row. I use the second row, multiply the first column, multiply the second column. So it's always row against column. All right. So let's start. So I'm starting with the first row. Okay. So don't forget the position. So for the first row, we go against the first column. All right. So I hope you are ready. Okay, so let's start. So this is the first row. So I'm starting with minus 2. That's going to be minus 2 multiplied by p. That's minus 2p. Then, of course, plus. Then I have 1 in that same row. 1, okay, because the first element with the first element of the column, the second element of the row will go against the second element of the column. So that's going to be 1 multiplied by r. All right, that's going to be 1r, just r, okay? So I've actually done multiply that first row against the first column. Okay, so now I will do the same. The same first row will go against second column. So I'm having minus 2 multiplied by q. That's going to be minus 2q. All right, this against this, then of course this against this. Okay, then plus 1 multiplied by x. Okay, so that's going to be 1x. All right, so that is it for the first row. I'll do the same with the second row. The second row will multiply the first column and the second column. So I go, right, 2 times p will give me 2p. Then, of course, 3 times r. That's going to be plus 3r. All right? Okay, so I go against the second column. 2 times q will give me 2q, of course. Then 3 times x will give me 3x. Okay, so this is going to be equal to 1, 0, of course, 0, 1. So with what I have here now, you know very well that it is very much easy for me to solve for r, right? So I'm going to equate. So how do I equate? Okay, it's much easy. So what I'm going to do is that let me equate this. Minus 2p plus r, okay, is equal to 0. Okay, so I'm looking, let's look at the second, what I have here. Here 2p plus 3r. Please pardon me, minus 2p plus r. The first element here is equal to the first element of the left-hand side, which of course is equal to 1. So here 2p plus 3r is equal to 0. So this is equation 1. And of course, this is equation 2. Okay. So it is easy now for me to solve this. So I can actually solve this by, of course, eliminating p. So if I add equation 1 and equation 2, p will be eliminated, right? So if I add the two equations, equation 1 plus equation 2, it's going to be easy for me to eliminate P. Minus 2P plus 2P will give me 0, all right? So P is eliminated. Then I have R plus 3R, all right? That's going to give me 4R. 1 plus 0 is equal to 1. So definitely my R is going to be equal to 1 all over 4. Okay, so as simple as that. Okay. Okay, something similar. Something similar right here. Okay, so solution. I can actually take that up a bit. Okay, so I'm good. Okay, so at this point, you know what we do? We multiply row against column. Row against column. All right, so let's start. So this first row will multiply only the first column, but I only have one column for the second matrix. Then the second row will still multiply the that column, right? Let's do that. 2p multiplied by 1 is 2p. Then, of course, 8 multiplied by 2. All right? That is 16. Okay? Okay, so second row, do the same thing. 3 times 1. Of course, that's 3 times 1, okay? Then of plus minus 5q multiplied by 2. All right? Minus 5q multiplied by 2. That should give me minus 10q. All right? So, of course, what I have is minus 10q. So, there's no need of writing this minus right here. So, this is going to be minus 10q. Okay, so it's equal to 24 minus 17. Okay, so now we can equate. Okay, so as you can see here, 2p plus 16 is equal to 24. So from here, I can actually find the value of p, right? Of course, for me to find the value of p, all I just need to do is I take 16 to the other side. That's going to be 24 minus 16, right? Of course, I'd have to divide by these 2. Divide by 2. 24 minus 16. That should actually give us 8, right? Okay, so that's going to be 8 all over 2, which is 4. Then let's solve for Q, right? So solving for Q, I'm having 3 minus 10Q is equal to 17. So that simply means that if you arrange this equation, I can actually take, all right, the minus Q to this other side of the equation. So I'm going to have 3 minus 17, of course, is going to be equal to 10Q, right? So 3 minus 17, okay? Right, so 3 minus 17, what do we have? That should be minus 14 if I'm not mistaken. Okay? It's equal to 10Q. So Q now is going to be equal to minus 14 all over 10. So if I use 2 to divide, 2 go into 14, I'm having minus 7 to go into 10, that's going to be 5. So this is going to be one whole number minus, oh, please pardon me. That's supposed to be minus one whole number. Minus one whole number, then 2 all over 5. Okay, so as simple as that. Okay, so that is what I have for you for this video, right? So we're going to look at more in the next video. Okay, so see you in the next video. Thank you very much.